the history of the whole numbers. Okay, let's begin. Negative numbers date back a long time. For example, the Greeks used negative quantities in their Greek mathematics, but more like properties of the subtraction operation. The first record of its existence is in the middle of the 5th century in the East, where positive and negative numbers were manipulated with tools such as abacus or balls of different colors, in problems such as counting or money management. It was thanks to the Indians that positive and negative amounts began to be differentiated, giving them meaning as credit and debit, respectively. The Indian mathematician Brahmagupta contributed to algebra representing negative solutions for quadratic equations. It is important to emphasize that, that it is thanks to this culture that we also have zero in our number system. It wasn't until the 15th century that the things we use it today, plus and minus, became popular, thanks to Stiefel. Before that, the abbreviation P was used for positive and M for negatives. It should be clarified that for Stiefel, these numbers were also absurd. Until the end of the 18th century, negative numbers were not officially accepted in mathematics because they do not have much meaning in the sensible world. For example, in operations such as multiplication, when operating two negative quantities, the result is positive. In the real world, this is not possible. Many mathematicians in the 16th century worked intensely to justify the rejection of this numerical system, such as Girolamo Cardano, who called them false numbers. John Wallis demonstrated the impossibility of their existence. For that time, his arguments were correct. Francois Vital discarded them for complete, or discarded, will accepted them in part, but called the negative roots of equations false because they pretend to represent numbers less than nothing. However, absolute rejection was not the only position. Scholars like Nicholas Schuket worked on the subject. For example, it is believed that he was the first to recognize zero and negative as exponents. He solved problems that led to negative solution using the algebraic substitution method. He resorted to equivalent semantic forms to be able to interpret the negative of the solution and introduced a syncopated language where the generality of his notation is very close to the symbolization of current algebra. As a curiosity, Choquet also worked as a doctor. It wasn't until the 18th century that great figures like Gauss, Euler, Cauchy, and Peacock began the hard work of formalizing the system of integers. Finally, Hermann Hankel, late 19th century, in his Astronomies, work on complex numbers and quaternions managed to formalize these complex systems. But sadly, this is not a story with a happy ending, because to formalize them something that had never been unthinkable up to now had to be sacrificed. They believed that mathematics constitute a body of truths about the nature, which meant a bridge between the world of mathematics and the real world. Thus, The integers, together with the operation of addition and multiplication, were given the mathematical ring structure with order relation. And not begin more, I appreciate your attentive listening. I give way to my classmate Valeria. Thanks.